Now for each subinterval, consider its maximum point on the parabola, which means the point for which the value of f is maximum for that subinterval. For instance, for the general subinterval, consider this, which value of f for that is maximum for this subinterval, okay? And draw horizontal line again. Now let's start by the last subinterval and draw horizontal line till, it intersect the next vertical line. And here also for the ith interval, here for the second interval, and here for the first interval. And this time, for instance, for the ith interval, the area under the parabola for this subinterval, which is area of here, is this side smaller than the area of this rectangle. Okay, and what is the area of this rectangle? Is smaller than 3/n the length of this side times the length of this side. And what is the length of this side? This is, again, this point, the x-coordinate of this point was this. So, what is the x-coordinate for this point? It is, it is the beginning point of the next subinterval. So, here, and the next subinterval is the i+1 interval. i+1 interval. Okay? So here, plug i+1 into I. So that would be 1 plus 3i over n. The i+1 minus 1 is I. Okay? So, square. Because the length of this side is the f of this point, which x-coordinate is this, 1 plus 3i over n. Okay? Now, here, since we got n subintervals, so we got n of such inequalities. Okay? 1 for each subinterval. 1 inequality for each subinterval. And if we add these left sides of the n inequality together and the middle ones together and the right sides together, we're gonna have sigma I from 1 to I equals 1 to I equals n. Okay, and for this also, let's write sigma behind it. It is also from I equals 1 to I equals n, and here we also got the sigma adding the corresponding of each inequality. So, and now here, what is sigma ai? You know, for instance, ai here was the area under parabola above the ith subinterval between the two vertical lines. So, and adding the ai, a1, a2, a2, an gives us the whole area, that the thing we are trying to calculate, the whole area under parabola above x-axis between two vertical lines. So this is a, let's show that by a, and one other thing here is that we call this sum, this sigma, or this is a sum, okay, we call this sum as the left Riemann sum, and this one, we call this one the right Riemann sum. And Riemann was the name of the mathematician, I guess, did these things for the first time. Anyway, you know, and this is this sum, or the left Riemann sum, is a function of n. So here left, we show that by LR of n, left Riemann of n, and the right Riemann of n. Okay, now let's calculate them, the left and right Riemann sum. Let's get rid of this. Okay. First, the left Riemann sum. You know, here this is equal to this for I equals to 1, plus again this for I equals to 2, plus this for I equals to 3, 2I equals to n. And you know, for each term of that, we got 3 over n. You know, if I be equals to 2, we got 3 over n, and if I be equals to 10, we also got 3 over n. So 3 over n is in every of them, so we could take it outside. 3 over n, I equals to n times 1 plus I minus 1 squared. Okay, now I equals to n. Okay, now this is inside the parentheses, this is sigma I equals 1 to I equals n, and this is 1 plus 1 squared plus 3 over n times I minus 1 squared, or 9 n squared I minus 1 squared plus double of their product, which is 6 I minus 1 over n. Okay,